So what are galaxies made of? What are we made of? What are you and I made of? We're made of atoms. We're made of protons and neutrons and electrons that stick together in certain ways and make certain molecules and different atoms. The most common element in the universe is hydrogen, which is just a proton and an electron orbiting it. Every element is a certain number of protons with a certain number of electrons. The number of protons determines the atom. The simplest atom is hydrogen. It is the most abundant element in the universe. 90%. I mean, it's a huge amount, more than 90%. Okay, then you have helium. That's the next most common element. Helium. So stars are made out of hydrogen. When hydrogen burns, it creates helium. So stars are burning and producing helium. When helium burns, it produces carbon. So we are, these top three, these are the most abundant elements in the universe, mostly hydrogen and helium, and then you've got some carbon. Then you've got nitrogen, oxygen, neon, magnesium, silicon, iron, sulfur, and iron. All these elements are produced. So hydrogen burns, produces helium. When helium burns, it produces carbon. When carbon burns, it produces nitrogen and oxygen and neon and magnesium. When silicon burns, it produces sulfur and iron. And when you produce iron in a star, it explodes as a supernova. So if you want to know where all the iron in your blood comes from, where all the silicon in your iPhone processor comes from, where all the oxygen in the air you're breathing comes from, or the neon in your open sign at a restaurant, or the sulfur in your stinky eggs. Okay, all of those atoms were produced in a star or in multiple stars, and then when they blew up, they spread that stuff around and then produced all the planets and all the other things that we're using. So at the smallest scale, you have an atom, and an atom is a proton with an electron orbiting it. And that's hydrogen. If you have two protons, it becomes helium. You have three, and so on. You boron and lithium and all the other atoms. Okay, and that's at the smallest scale. So what an astronomer is doing is trying to measure the abundances of these, or the relative abundances. How much hydrogen is there? How much helium is there? How much carbon is there? Because think about it. If most of the stuff is still hydrogen, that means the universe has to be relatively young compared to the life cycle of a star. Because if stars, when they burn hydrogen into helium, if the universe had been around long enough for all the hydrogen to be converted into helium, instead of hydrogen and then helium and then so on, we would have hydrogen and helium. So the relative abundances tell us kind of where we are on the scale of the history of the universe. So we're at still, even though it's about 13.7 billion years since what we call the Big Bang, or the beginning of our universe, since most of it is still hydrogen, we've got a long way to go till we burn through all that hydrogen and use all of that up before we run out of stuff to make stars out of, and then all the stars die, and then the universe is just dark, which is going to happen someday, but it's a long time. Don't worry about it.